In today's digital age, mobile application or web applications have become an integral part of our daily lives. From social media to e-commerce and everything in between, mobile apps have transformed the way we interact with technology and each other. As a result, app development has become a highly sought after skill set, with developers around the world creating innovative and cutting edge applications to meet the needs of consumers and business alike. Also, the salaries offered for these roles are quite lucrative in comparison to other IT profiles. So, if you are interested in the solution development and computer science while having plans for earning really fat paychecks, learning about app development and its recent trends is quite worthwhile. With today's session, we are going to introduce you to one tool that had just shown up in the Python community and has amazing features when it comes to app development. It extends the Flutter app development with Python and it is named as Flet. Today, throughout this session, we are going to explore what it is and what it has to offer. But before we begin with that, make sure to enable that subscribe button and bell icon so that you don't miss any update coming from our Intellipaat YouTube channel. First of all, let's look into the agenda for this session. We'll begin this session on a friendly note by getting introduced to the Python Flet framework. Then we shall go and understand the basic program structure for Python Flet. Finally, towards the end, we'll create a real-time iPhone-like calculator app using Python Flet. I hope the agenda for this session is clear to all of you guys out there.
So let's begin with the first topic on our agenda, that is understanding what this Python Flet is all about. Flet is a Python web development library that enables developers to create real-time web applications using familiar Python syntax. It is built on top of the Flask web framework and uses WebSockets to facilitate real-time communication between the server and client. At its core, Flet provides an abstraction layer over WebSockets, which simplifies the process of building real-time applications. This means that developers can focus on the logic of their application rather than the intricacies of WebSocket communication. Flet offers a simple and intuitive API that developers can use to create real-time web applications. The library provides built-in components such as forms, tables, and charts which developers can use to quickly create functional applications. One of the key features of Flet is its support for server-side events. With Flet, developers can easily create event-driven applications that update in real time as data changes on the server. Another key feature of Flet is its support for WebSocket authentication. This allows developers to restrict access to their applications to authorized users only, which is crucial for building secure real-time applications. Flet also supports asynchronous programming, which is critical for again building efficient applications. Flet also supports asynchronous programming, which is yet another critical component when it comes to building efficient applications. The library provides a simple and intuitive API for writing asynchronous code, which makes it easy for developers to take advantage of these features. In addition to these features, Flet also provides several tools for debugging and testing real-time applications. For example, the library includes a WebSocket testing client that developers can use to test their application in controlled environment. To use Flet, developers first need to install the library and its dependencies. Once installed, they can import Flet and start building their application using Python syntax. Flet includes a built-in development server which developers can use to test their applications locally before deploying them to a production environment. Overall, the Flet is a powerful tool for building real-time web applications in Python. Its simple and intuitive API supports for server-side events and WebSocket authentication, and asynchronous programming capabilities make it an excellent choice for building modern and dynamic applications. With Flet, developers can leverage their existing Python skills to create fast and efficient applications. Moving forward, let me cover the basic program structure of Flet. The basic program structure for Flet is similar to that of Flask application, since Flet is built on top of Flask. You can see the basic steps for creating Flet application on your screen. A typical Flet program always ends with a call to flet.app function where the app starts waiting for new user session. Function main is an empty point in a Flet application. It's being called on a new thread for every user session with a page instance passed into it. When running Flet app in the browser, a new user session is started for every open tab or page. When running as a desktop app, there is only one session created. Page is like a canvas specific to a user, a visual state of a user session. To build an application UI, you add and remove controls to a page. Code sample above will be just displaying just a blank page to every user. Let me visit the code editor to show you that. So here, once I run this code, you could see that there is nothing available on our screen, right? We are just seeing one buffering button which suggests that the page has been created and the session has been created as well. Now, let's provide some sort of command to this main block. Typically, let's start with hello world statement itself. So in order to get that onto our page, all we have to do is we'll have to call the function page.add, and inside it we'll use the text option under the Flet library and we'll provide value hello world. Now once I run this code, you'll see that the hello world is getting printed on our output screen, right? That is our output application window. Now moving forward, we'll create an iPhone-like calculator by using the Flet framework. Here is the reference image that we are trying to target via our UI development and functionality programming. So let's visit the code editor and get started. First of all, let's create a new file. The code will again begin by importing the Flet library to our workspace. So we'll load Flet and assign it to alias ft for first. So the command to do that is import Flet as ft. Then we'll define the main function and inside it we'll pass page as an argument. Now the title that we are going to give to this page will be calc app. Also we'll have result over here. So initially the placeholder value for this result will be 0. So we'll assign the value. Now the next thing will be adding the different buttons to our application. Basically the buttons that we need to add are the numbers such as 1, 2, 3, 4, 5, 6 till 9, 0 as well as plus, minus, multiplication buttons and one AC button which will change the state of our result. Alright, so basically let's add these buttons one by one, and the button that we are going to use for this purpose is going to be elevated button. And in order to add all of these buttons to our page, we'll have to use page.add function as discussed earlier. So to this page.add function, we'll pass result, which will be 0 initially, then all other buttons such as ft.elevated button, and the text for this button is going to be AC. Now similarly, we'll paste more such buttons.
Now these are the all the buttons that basically every calculator contains. Now let's also add the ending statement so that we would be able to run this snippet of code. So we'll provide target dot main argument over here. Now let's run this code and visualize what output we are getting over here. Before that we'll have to save this, so we'll save it as calc1. Over here you can see that all the buttons are available on our screen and they are not aligned according to the layout that basic calculator app has, because we have just randomly added the buttons over here. Now in order to add the layout into these buttons, we have to use the function named as rows. So let's make use of it and insert the layout into our calculator application lookout. So if you check this app interface, you can see that there are total 6 rows. Here is the first row which represents result. After that we have 5 rows which contains numerical buttons as well as the operational buttons as well. So basically in similar way we'll have to create the 6 rows for our calculator layout as well. So let's go to the code editor and begin with that. So basically guys, row is a control that displays its children in a horizontal way. So in our case, these elevated buttons are going to be the children that we want to be arranged in a horizontal way that we just saw in a PPT part. Alright, so in order to get this done, we'll have to make use of this row function. So the first row is going to be the result block. So ft.row and the controls will be equal to result. Now for the next row we are going to have multiple buttons. So ft.row and the controls will contain AC button, plus minus button, modulus button and division button as well. After that we'll have the third row which will contain 7, 8, 9 and star. Similarly, the fourth row then we'll have the fifth row with controls 1, 2, 3 and plus sign. And after that will come the final and sixth row Alright, now let's run this snippet of code. Here you can see that we are getting the layout in proper manner.
So basically all the buttons are arranged according to the basic calculator layout that we have discussed earlier. Now all we have to do is design this using the different elements of Flet library. So the element that we are going to use for this purpose is going to be the container. We'll discuss about that by going to the PowerPoint slide. So now the question here is what exactly this container function is. So guys, container is a function in Flet library that creates a container control with a layout that can be customized by the developer. The function takes in various parameters such as width, height, content, background color, padding, border radius and border to customize the container's appearance. So basically background color, padding as well as border radius, the border size are the values that developer will set while developing the application. In case of our calculator, the background color is going to be black for all the different rows. So basically instead of creating multiple containers, we'll have to create only one container and merge all these 6 rows into single vertical column so that now to complete the UI portion of the program, we'll have to update the color size, properties of the text, background color, the color of text, padding and alignments as well. So let's go to the code editor and understand how this is done. So guys, instead of writing the whole long code, what I'll do is I'll explain the code section by section. It will save a lot of time and will also be easy for you guys to contemplate and look at for. So let me show you guys the code. So here is the code for our application. I have divided this code into 2 sections. One function named as build creates the UI for our application and the rest of the functions over here such as button clicked, then format number, calculate, creates the functionalities for different operations as well as clicks on the buttons. Now let's begin from start. So for the first line we are importing the Flet framework, and in the second line what we have done is instead of importing Flet as an alias, what we have done here is we have imported all the functionalities that we are going to need throughout the program over here. By doing so, we don't have to use .ft throughout the code. Now let's talk a little more about modules that we are using over here. First we have is column. Basically guys, column is a Flet layout control that arranges its child controls in vertical order. Then we have container over here. As discussed earlier, it is a control that contains other controls. In our case, it will contain one column which will be holding 6 rows, right? Now next class we have here is elevated button. It's a button control with an elevated appearance in the context of design. We have seen it in output screen as well. Then we have page, row and text, which we have discussed about already. After that, we have user control. Basically, it's a base class for creating custom user controls, and our UI class is going to be extend this base class itself. Basically, user control is typically used as a base class for building reusable UI elements that have a specific functionality or behavior. It is essentially a container that can host other UI elements such as buttons, text boxes or images. It can also define its own properties, events and methods that can be used to customize its appearance or behavior. Then next we have is border radius and colors. Border radius is a module that provides constants for setting the border radius of a control, whereas colors provides constants for setting the colors of the controls. Now let's talk about this code over here. So this code defines a class called calculator app that inherits from user control. Calculator app is likely a custom user interface component that represents a calculator application. By inheriting from user control, the calculator app class inherits all the properties and methods of user control and can be used as a building block for creating more complex UI layouts. The build method is defined within this calculator app class, which is a common method used in many UI development frameworks to initialize and construct the user interface component. In this case, the build method is responsible for setting up the initial state of the calculator. Within the build method, you can see the reset method is called. Basically, this method is going to set the calculator to its default state. The reset method is basically a custom method defined within the calculator app class, resets the calculator's internal state, such as clearing the input buffer and resetting the current operation. Next, you guys can see that a text component is created and assigned to the self.result attribute of the calculator app instance. The text component represents the display area of the calculator where the results of calculations are going to be shown. The value argument sets the initial value of the text component to 0, indicating that the calculator should start with 0 as the initial value. The color argument sets the text color to white and the size argument sets the font size to 20. Now moving forward, let's talk about this block of code. These particular lines of codes create a container UI element with several custom properties. A container is a rectangular UI element that can be used to group other UI elements together. Here this container of ours is going to hold the single column as we mentioned earlier by referring to the structure slide a while ago. The container has multiple UI properties over here, such as background color, border radius and padding. All this stuff is assigned as per the iPhone calculator UI image we saw earlier. Now next you can see the column which contains multiple rows, right? So the first row here contains the result control. After that, you can see that each row contains multiple elevated buttons. For example, the second row contains AC, plus minus, modulus and divide button. And similarly, the third row contains more buttons, fourth row contains more buttons, fifth row contains more buttons and so the sixth row. Also, all of these rows are wrapped inside a singular column. Also here in each elevated button, you could see multiple factors such as color, background color, text on the button and expand function. So remember, for rows 2, 3, 4 and 5, buttons are going to be in 1:1:1:1 format. Hence, we'll be setting expand to 1 for each of the content in these particular rows. But for 6th row, we'll make the 0 button bigger by setting expand to 2. So let me show that to you guys. So here you can see that we have set expand to 2. So in 6th row, buttons will be in 2:1:1 format. Besides that, you could also see function names as button clicked and an action element on click, right? So now this is something that is going to add functionality to our UI buttons. So let's talk about the code for this function as well. So this is the code for button clicked method. This code defines a method button clicked that is a handler for a button clicks in a calculator app. The E parameter represents the event that triggered the button click. The code first extracts the data properly from the button control that was clicked. This property is used to identify which buttons was clicked. The method then performs series of conditional statements over here. Alright. Now each conditional statement handles a specific type of button click. Now for example, let's say if data is AC or the calculator's display currently shows error, the calculator is reset to its initial state where the display shows 0 and no operator or operand have been selected. If data is a digit or a decimal point, it is added to the current value on the calculator's display. Alright. If the current value is 0 or the user had just selected an operator, the current value is replaced with the new digit or decimal point. So if initially we have 0 on our result screen and if you press 1, 2, 3 or 4,
The number that you'll be seeing after that will be 1 on your screen. So system doesn't know how to do that on its own. So basically this conditional statement is going to add that functionality into our system. All right. Now also, if the data that is clicked on is going to be plus, minus, multiplication or division, then the calculator performs the previous operation with the current operand and displays the result. The new operator is then stored and the current operand is set to the result of the previous operation. If the result of the previous operation is error, the current operand is set to 0 basically. And then if data is equal to, then the calculator performs the previous operation with the current operand and displays the result. The calculator is then reset to its initial state when the operation is done. If data is modulus, the calculator converts the current value to a percentage by dividing it by 100. Now, similarly, if data is plus or minus, basically it is a sign convention change format. So it toggles the sign of current value. Finally, the update method is called to update the display with new value. Now with this function, we have handled all the states of the calculator basically, and what it should do when a certain button is pressed. However, the soul of the calculator is yet to be developed, that is, its ability to carry out mathematical calculations. Now, for that purpose, we have this calculate function over here. The calculate function is a method that takes 3 parameters, operand 1, operand 2, and operator. It performs the arithmetic calculations based on the operator parameter and returns the result. The available arithmetic operations are addition, subtraction, multiplication, division, etc. If the operator is division and the second operand or operand 2 is 0, it returns the string error instead of performing the division to avoid a divide by 0 error. The function self.format_number is called to format the calculated result before returning it. This function ensures that the return value has a maximum of 12 decimal places. Now let me show you the body of this format_number function. This function basically takes a single parameter, that is num. It checks if the input number is a whole number or not by using the modulo operator. If the modulo of num with 1 is 0, then it is a whole number, and the function returns the integer value of num by calling the int function over here. Also, if number is not a whole number, the function returns num as it is. This function is used by the calculate method of our calculator app class to format the calculated results. It ensures that the return value is an integer if the calculated result is a whole number and is returned as a float if it is not. Then there is this reset function over here. We are using this function to change the state of our calculator attributes. The operator attribute is set to plus by default, which is the default operator in calculator. The operand 1 attribute is set to 0, which is default value for the first operand in the calculator, right? I mean, that's the value you basically see all the time while you open the calculator. And the new operand is going to be set as true, which indicates that a new operand should be entered after an operator is pressed. This method is called in several places within the calculator app class, including when the calculator is first loaded and when the AC button is pressed. You can check it over here itself. You can see that when AC button is pressed, we have given a call to this reset function. Calling the reset method ensures that the calculator is in a known and consistent state before any new calculations are performed. Now that counts all of our program's functionalities. All that is left to be done is making calls to these methods via the main block. So this code over here is basically the main block that we are talking about. So what this does is it adds the instance of calculator app class
that is calc, to the page instance named as page. And for that purpose, it is using the add method of the page class. This effectively adds the user interface of the calculator application to the web page. Now, when the main function is called during the runtime, it sets the title of the page to calc app, creates an instance of the calculator app class named as calc, and then adds the calc instance to the page. This makes the calculator application available on the web page for the user to interact with. Now let me run this code and show you guys how the output window looks. Alright, here you could see this quite nice looking calculator app on your screens. Now let's check if it functions correctly or not. Let's add and multiply two numbers. First, I'll add 8 plus 2. This shall result in 10, which is right. Now let's press AC button and see if it is working or not. Now again I'll use 5 and use this sign convention change button, and you can see that it has converted 5 into -5. Now I'll multiply that with 6 and the result that we should get is -30, which is right again. So that's all we have for this session, guys. I hope all of you are clear with the amazing capabilities of Flet library and how you could put it to use for creating Flutter applications using Python instead of going and learning Dart. So go ahead, explore more about Flet, create amazing applications and user interfaces that will set you apart from all the competition out there in the software development industry. I wish you best of luck in that endeavor. If you have liked the concept covered in this session, do make sure to hit that thumbs up button. Also, consider subscribing to the Intellipaat YouTube channel so that you won't miss out more such technical updates from our team. Thank you once again for being here till the end of the video. Until next time, goodbye.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.